Today we're going to take a little excursion into special sums and specifically arithmetic series. This is going to be a useful tool down the road. However, before we do that, I want to tie into the previous video of advanced rationalizing where we saw stuff such as this. And there was a question of what happens if there's 3 terms in the denominator or even more, or there could be any other things. For example, let's say we have a square root of 7. So then let's try our advanced rationalizing approach, except now we are going to treat this as one term. So it's sort of a plus b. And so we're going to multiply by the conjugates, which means copy this but flip this sign. Now we don't need these parentheses, I'm just doing these for readability. Okay, so what's going to happen, I won't even bother with the top. Let's focus on the bottom, the denominator times the denominator. What's going to happen here is that when you multiply this by this, you will get root 2 times root 2, which is just 2. There'll be 1 root 6 from here and 1 root 6 from here, so that's 2 root 6. And then square root of 3 times the square root of 3 is just 3. And then positive root 7 times negative root 7 is just minus 7. So after we clean all of this up, notice these 3 are just numbers. So that will get us negative 2 plus 2 root 6. And now what we've done is gone from 3 terms down to 2. So then you would do this again and multiply this by the conjugate again. So it would be negative 2. To multiply this times by negative 2 minus 2 root 6, and then you will make progress and have no square roots in the denominator. So in other words, the advanced rationalizing approach works with more than just 2 terms in the denominator. All right. So let's go to today's topic, which is adding things such as this. So the dot 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 just means keep going in the same way, plus 5, 6, 7, 8, 9, 10, all the way till you hit 10. All right, the convention is you put a plus or whatever operation, then dot dot dot, 3 of them, and then the operation. So you don't just put dot dot dot, you put the plus, then dot dot dot, then plus again. So that's the convention. All right, so of course you can add all these numbers. So you can do 1 plus 2 is 3, plus 3 is 6. You can do all that out. But we want to be able to see this and do this very quickly. So you'll encounter such additions pretty frequently, which is why we're doing a separate video on this. All right, so how do we do this? The key idea is going to be the following. So first of all, let's take a scarier problem and let's go all the way up to 100. All right, so this is going to involve a few skills we've seen before. Some of you might start to guess that we don't want to just add all of them in order. So what we're going to do is we're going to use grouping. We're going to pair off 1 and 100. We're going to pair off 2 and 99. We're going to pair off 3 and 98 and so forth going inwards, because 1 plus 100 is 101. 2 plus 99 is 101. 101, all of them are 101. Now if you think about why we're doing this, it's sort of like a rectangle where you wouldn't bother counting all of these squares. You would say there's 6 by 5, so therefore there's 30 little squares. So the idea is the same. We're going to find the sum per pair and multiply that by the number of pairs. So in this case, the sum of every pair is 101. How many pairs are there? In this case, it's very easy to see there's 100 numbers. So since you're pairing 2 at a time, it will be 100 divided by 2, or 50. So I'm just going to write 100 divided by 2 so you can see where that number came from. Now we can multiply this out, 101 times 50, and get 5,050. I'm not so concerned about multiplying, I just care that you can set it up like this. From here, everybody should know how to multiply. All right. However, things can get more complicated, but this is the key idea. If you understand that we have to find these two numbers, then you're good. So the sum per pair, number of pairs. Now, let's look at a harder problem. And there's going to be two methods we're going to go over. So there's going to be what I call the shifting method, and there's going to be the distance method. So let's imagine we have two plus 4 plus 6 plus 8 all the way up to 200. So this time we're going to pair them up again. It'll be 198. So 2 plus 200 is 202. 4 plus 198, again 202. Everything's going to be 202. But we can't really see how many numbers we have. So we can do a few things. In this case, we see each number is really doubled. It's an even number, so if we divide each by 2, we could see that it runs from 1 to 100. So there's still 100 numbers, so there would still be 50 pairs. But let's see what we would do in general. So the shifting method, well, let's actually do a harder problem. But now you're beginning to see the trickier part is not finding the sum of every pair, but finding the number of pairs. So let's imagine these numbers are like this. Okay, now we can't divide them by 2 and see how, it's not easy to see how many numbers. So the sum of every pair is easy because it's 3 plus 199, so it's 202. That's the sum per pair. The number of pairs is not at all intuitive to see. So that's where these two methods come in. They're going to help us find the number of pairs. So the shifting method is going to be a little more involved, but it's going to give you a good understanding of what's going on. The distance method is a little more, it's a little faster. So a lot of people prefer the distance method. I think you should know both, but it's fine to have a preference. So just know you'll probably likely use the distance, but be aware of the shifting method. So for the shifting method, we're going to say, what would make this problem easier? Let's shift all of these to a multiple, since they're moving by 2s, let's shift them to a multiple of 2. So in this case, we can move this forwards or backwards, either to 2 or to 4, it doesn't matter. So let's say we move everything up by 1. So the 3 is going to become a 4, that's going to become a 6, 8, all the way up to 200. So now what's the advantage of this? Now they are all divisible by the step size, which is 2. So now we're going to divide everything by 2. So now this is 2, 3, 4, all the way to 100. Now notice we're messing with the numbers, and that's not okay, but it's okay for our purposes because we just want the number of pairs. We don't care if we mess up the numbers. We've already stuck to the original to find the sum per pair, so it's okay that we're annihilating these numbers. Okay, so now notice they're moving by 1s. Now if you go back to the habits counting lesson, off by 1, you'll remember how we count the number of numbers here. So we're moving from 2 through 100. So you might think that's 98 numbers, but if you think so, you should go back to the habits counting off by 1 video. This is 99 numbers. So that's the crucial thing we wanted to find. And since there's 99 numbers, there's 99 over 2 pairs. So at this point, some of you might be wondering, how can you have an odd, a non-integer number of pairs? This is 40, this is going to be 49.5. That doesn't make sense. However, this formula takes care of it, and here's why. Imagine we're adding 6, 7, and 8. So there's 3 numbers. So if we pair them up, there's only 1 pair, or you can think of it as 1.5 pairs. So there's 3 numbers, or 3 over 2 pairs. However, when we use this formula, the sum per pair would be 14. Now, this 7 is being counted as a 14, but only half of a time. So half of 14 is 7, so it all works out. In other words, you don't care if there's an odd number of numbers, an even number of numbers, this always works. So don't freak out if this is not going to be a whole number, because you're doubling it here to compensate for anything here. So it's always going to work out. Go back to this little example to see why it makes sense. All right. So in the shifting method, we shifted all the numbers, either mentally or on paper. So this went to 4, this went to 6, all the way to 200. So we shifted everything by 1, then we divided it by 2. And then finally we saw they move like this. Now here they're moving by 1s, and it's very easy to see that there's 99 numbers. It's 100 minus 2 plus 1. Okay, that's the formula for how to find the number of numbers. Again, review the habits counting off by 1 video. All right, that's the shifting method. Let's go into the distance method. The distance method, we're going to say, what is the distance from 3 to 199? Well, that's 196. Okay, what's our step size? We're moving by 2. So how many steps are we going to have to take if we are going to travel 196 units moving in 2s? We just have to divide this by 2. So that's 98 steps. Now remember, since there's 98 steps, the number of numbers is 1 more, 99, because we have to consider our initial starting point. Because when you step, you don't count the initial starting point. So we get the same 99. Since there's 99 numbers, there's 99 over 2 pairs. So that's an example of how to use each method in this problem. Now let's do 2 more problems so we could see how this can get a little trickier. So let's say we have something like this. Now, I can't arbitrarily just make up, these are moving by 3s, but I can't arbitrarily make up this number. If you've noticed, each one is 1 more than a multiple of 3. So this is 1 more than 3, 1 more than 6, 1 more than 9. I have to stop on something that's 1 more than a multiple of 3, which 96 is. All right, so the shifting method, let's move them to a multiple of the step size, which is 3. So that means let's go down by 1. So these become this. Now we're going to divide everything by 3. So this turns into 1. This turns into 2. I mean, we really only care about the ends. So this turns into 32. So in this case, it's very easy to see 1 to 32, there's 32 numbers. So 32 over 2 is the number of pairs. The sum per pair is 101. So 101 times 16 would be this sum. All right. Now let's try the distance method. So the distance method, again, the 101 stays the same for the sum per pair. We're going to see what's the distance from 4 to 97. So the distance is 93. What's the number of steps? The step size is 3, so we have to travel this in steps of 3, so that's 31 steps. But remember, you have to count the starting point. So the number of numbers is 1 more, so it's 32, just like we got before. So there's 32 over 2 pairs. So these work out to be the same thing. I might be writing about the same for these, but you could do all of this without writing any of this. So you could say, I'm traveling 93 units in steps of 3, so that's 31 steps. Add 1, you get 32 over 2 pairs. All right, so now let's do something slightly trickier, which is going to be something like this. All right, so notice we're starting with negative numbers here. So these are going to work the same, you just have to be careful with the negatives. So let's use the shifting method first. Again, you don't have to use both methods for every problem. I'm just showing you how you would do that. So for the shifting method, we're going to move these to the closest multiple of the step size, which is 3. So negative 15 is the closest. So let's move this up 1, not down 1, but up 1. Because that makes this negative 15, negative 12, negative 9. All the way up to 36. All right, now we're going to divide everything by 3. And now we're going from negative 5 to positive 12 in integers. And so that means there's 12 minus negative 5, which is 17, plus 1 from that counting video. So that's 18 numbers. So there's 18 numbers, so there's 18 over 2 pairs. The sum per pair, you add these two numbers, careful with the negative. So it's going to be 19, because negative 6 plus 35 is 19. So 19 times 9 would be your answer. All right, that's the shifting method. Distance method, again, you would have the same 19 for the sum per pair. And then you see, how far are we going from negative 16 to positive 35? For that, you could do 35 minus the starting point. So 35 minus a negative, is going to be 51. So the distance is 51. We're moving in threes, so you're actually taking 17 steps, and the number of numbers is 18 because it's one more than the number of steps. So again, it would be 19 times 18 over 2, and if you notice, we got the same answers with the first method. All right, so that's how you use the shifting method and the distance method to find the sum of an arithmetic series. Quick note, sequence means just a pattern of numbers. So this is a sequence. This is a series. It has pluses. That's all the differences. Now, final little trick question, and then we'll wrap up this video. All right, so a lot of you might be starting to use this and say, okay, let's group them, let's find the sum per pair, the number of pairs. But if you look at these numbers, you notice most of them will cancel out. In fact, negative 16 is going to go all the way through positive 16, and everything is going to eliminate each other. Negative 16, positive 16, gone. Negative 15, positive 15, gone. So the only thing that's going to be left is going to be 17 and 18. So the answer is 35. All right, see you guys in the next video.